and welcome to this presentation. My name is Sidsel Boldsen and I'm a PhD student from the University of Copenhagen. I would like to present the paper Survey and Reproduction of Computational Approaches to Dating of Historical Texts, which is joint work together with Frederik Valberg. So in recent years, historical text archives are being digitized extensively, and in this paper we work with automated dating of those. So if we have methods for automated dating, if we in digital archives are missing metadata on when the texts were written, then we can use such methods to fill in the blank of metadata and placing them on a timeline. So for scholars who wish to work with historical text on a diachronic basis, such methods could be useful. And on the other hand, if a digital archive already contains such metadata, these methods can be used to evaluate, to try to identify whether we see any documents which is might be misplaced. So for example, identifying copies of earlier editions. And also, having trained such methods, and if successful, we might even learn something from them that could contribute within the field of philology. So if they're able to successfully date documents, what did they learn? But of course this sets a requirement to the models to being interpretative. So in this paper, we only work with the first problem of, and we try to evaluate how well methods from literature are able to fill in the blanks of the data. So how well are they actually able to date historical texts? So yeah, we we evaluate the methods from literature and how they apply to historical data sets. And the audience of this contribution is both philologists who wish to apply such methods in their work and to their respective datasets to get a feeling of what's actually possible, but also computational linguists who wish to get an overview of the methods in literature. And the dataset that we are working with are two collections of medieval charters, one from Denmark and one from Sweden. So they differ quite in size, with the Danish collection being small. There's around 500 charters, most of which is written in Latin, and some 100 are written in Danish. This is contrary to the Swedish collection, which is a lot larger, with around 11,000 charters. And again, most of them are written in Latin, and they are roughly from the same period. So what distinguishes these two collections, apart from size, is the fact that the charters of St. Clair Convent are transcribed in two different ways. So we have the standard diplomatic version, as you can see in example B, but then we also include a more a transcription closer to the original facsimile. So I'll first start by going over computational approaches found in literature to the dating of texts, and then I will go through our experimental setup, where we survey how these methods can be applied to historical data sets. I'll now go over the different approaches to dating, and one of the first problems is how to actually represent our documents. So if explicit temporal references are given in the text, the problem can be reduced to the passing of those resolving whether they refer to the date that the text was written or to, for example, previous events. However, if no temporal reference exists, such methods are not sufficient, and the date of a text will have to be inferred implicitly. So in this paper, we treat the problem of dating historical text, and here temporal references are usually not given, and thus we will only focus on the latter type of implicit inference. And here the issue is then, so what features are predictive of time? And usually in literature, you either treat the documents as word or character features. So word features might model topological variation, lexical variation, which could be predictive of time, while character features at least have the capability to capture more structural features such as spelling or morphology. And syntactic features can also be used if the texts are, for example, annotated with past tense. So having represented our documents, we can then train a classifier to try to solve this problem. And one of the earliest methods for doing this is temporal language modeling. So here the problem is reduced to finding the language model that fits the document in question the best. So trying to maximize the probability of having observed that document. So here we train a language model for each temporal period, and then we simply assign the document the label of the language model that fits the data the best. Later approaches is more traditional in the sense that we train a classifier to the problem and to map the document to a label. And here several methods have been used, naive Bayes, support vector machines, also Gaussian process, which is a regression method, and in recent years also neural networks. However, we will not go through neural approaches as our data sets are relatively small. So now to our experimental setup for this survey. So the dataset I already went over, but here it's important to note that we separate the Latin from the Swedish charters and as well the Latin from the Danish charters, treating them as separate datasets. Also for the Danish charters, we try to use both the diplomatic and the facsimile transcriptions. And for comparison, we also use two other datasets treated in literature. The Colonia dataset, which contains books in Portuguese ranging from the 16th to the 20th century. And then the data from the Sameval task and diachronic text evaluation from 2015, which contains shorter news snippets in English. And they're relatively more modern, or they're from the 18th to the 21st century. And for representing the text, we use both word and character n-grams, ranging from bigrams to trigrams. And the methods that we evaluate is first the temporal language model, then an SVM with both a linear and a non-linear kernel, and then naive Bayes, both multinomial and Gaussian, and then Gaussian process regression. And for evaluation, we use accuracy as a metric with a bin size of 25 years. And that also goes for the regression approach. So while training, it treats the timeline as continuous, but not during evaluation. And for baseline, we choose a random baseline, choosing labels at random, and then a weighted version, choosing labels according to their frequency, and then at last a majority vote, which always chooses the most common label. So for the results, firstly, we see the baseline to the right, which is the majority vote, and to the left, you see the best performing models. So the temporal LM at a character level of bigrams and trigrams performed the best or received the best results on 5 datasets, while the SVM with RBF at a character level had the best results for Colonia and Sinclair at a diplomatic level, the Danish ones. And at last, the Gaussian naive Bayes, as the only model on a word level, received the best results than for the Latin diplomatic version of Sinclair dataset. So now for the discussion, what can we learn from these results? So first, considering the feature sets that we use, character versus words. So in all datasets except of the Sinclair at the diplomatic level, we see that the character models perform the best. So, and why could this be? Is it because words capture topological features while characters are able to capture more subtle structural variation? It's difficult to say. The character features are also more efficient, you could say, in how they treat the data, and less sparse. So whether the good results for the character models are due to the actual variation that they capture, or that they're simply more efficient, is difficult to say from these results. And to the performance of the individual models, so we we included a regression method in our experiments, but we didn't see that it had any advantage compared to the classification methods. And surprisingly, the temporal language model seemed to perform very well, even though it is mostly treated in early literature. And in our paper, we tried to discuss why this could be. So all of the estimators that we evaluate try to describe language as a distribution of words or characters. However, most of the estimators that we train, they treat the documents as points in a Euclidean space, for example, the linear SVM. And this assumption often works. However, using a diversion metric, the space of documents is treated more in line with how they're actually encoded in the first place. And this has been shown to be beneficial for image-based dating of manuscripts. And it might be that this result is also valid here for documents. So the datasets that we treated are very different with respect to size and length of the individual samples. And it's difficult to say how the different models perform with respect to such dataset characteristics. We couldn't see many patterns, but for example, comparing the results for the STHK Latin and the SEM-eval datasets, they're very similar with respect to the number of data points and the distribution of the different data points. However, the SEM-eval has shorter text instances, and whether this is these shorter texts is at play when seeing a lower performance on the SEM-eval, or whether this is due to the fact that the SEM-eval dataset is from a later period and might be more difficult to date. In general, it's difficult to say. And for future work, I would like to mention interpretability. So we discussed, for example, what is the best character or word features, and it's difficult to say why one performs better than the other. And here, the interpretability of the models is important. And also, so when we evaluate these models, we evaluate on the same data set that in which they were trained, and if the goal is to and this is what you usually do in literature, but the actual estimate of the performance is very optimistic and not really real world like. So it would be interesting to see how will these methods trained on one data set generalize to another from the same period. And then at last, so recent approaches to non-historical text, also modern text, have used neural models, and it would be interesting to see how and if these can be applied to historical data set. So yeah, thank you a lot